Uncle Bob, the man who wrote clean code, just went viral saying he doesn't read the code his AI agents write at all. And he's the guy who taught the generation to read every line and make the code clean. And here is the crazy part. AI bugs are up 55%, and that's from a study of 22,000 developers. Incidents per change up to 245%. So bugs are exploding, and the masters are leading less code? Sounds insane. But it's not. Look at your own team. More code than ever, same reviewers, same deadlines. You won't be more productive if you try to read every line of AI code. But then how do you trust that the code actually works? The answer is to have something stronger than your eyes reading the code. Testing just became the most valuable skill in software. So in this video, I will show you my entire defense system, 5 testers standing between AI code and production. And none of them is human. I delegate all of it to AI agents. And at the end of the video, I will show you how to build this exact scheme for your own code base so you can steal the whole thing. I've spent 15 years on mission-critical systems. And here is my confession. I stopped writing unit tests. There is nothing worse than a green test suite with everything mocked out. A green line is worse than no test at all. So I moved from the testing pyramid to the testing diamond. Most of my tests today are integration tests, and they run against the real thing. They hit a real database, a real message broker. So I need less mocking, I have better realism, and higher confidence. For pure logic, unit tests are still fine. What I stopped is mocking everything else. And with AI, this matters more than ever. AI hallucinates about infrastructure, and the mock happily plays along with every wrong assumption. And the real database refuses to. To write integration tests, I use test containers. One line in my test, and the real Postgres database spins up in a Docker. It runs my test against the real thing, and the container dies after. No mocks, no shared staging database. I use the following rule. If the code touches infrastructure, test it against the real infrastructure. And I don't write these tests myself. My integration tester agent does. I will show you the blueprint and the end. So now my test hits the real thing. But that raises a harder question. How do I know my tests are actually testing the right thing? The answer is not code coverage. It's 2026 and I still meet a lot of teams that rely on code coverage. They use it in their CI, aim for at least 90% code coverage, and when they reach it, they are happy to deploy to production. The problem is that code coverage is not a quality metric. Let me show you on TicketBay, a little booking platform I built for this video. This module has 100% code coverage. Don't watch me. I delete every single assertion. The checks that verify that the code works. Now I run the code coverage again. The result? Still 100% code coverage. So, do you still trust your tests? Code coverage can help detect untested areas of the code, but it doesn't tell you anything about the tested areas. How can we measure the quality of our tests then? The answer is mutation testing. Mutation testing introduces changes to your code, small mutants, then runs your test against the changed code. It is expected that your tests will now fail. If they don't fail, it might indicate that your tests do not sufficiently cover the code. It's that easy. One example. Flip an arithmetic comparison, a greater or equal into a greater than, then run your tests. If nothing fails, then that line was never really tested. But doing that by hand is slow, so I use Striker mutation testing framework. It mutates the whole code base automatically, and its reports show you every mutant your tests fail to kill. So I created a mutation testing agent that runs it and explains every survivor in plain language, what lie the test suite is telling. And the next tester wants code money literally vanishing from a financial system, fractions of a cent at a time. In a financial system I worked on, one rule stood above everything. The system itself must never create or destroy money. People transfer money between each other, a currency conversion happens, so the money can move from left to right. But the total money supply has to be the same all the time. Not roughly, not to the cent, to the 12th decimal. But once we had a rounding error in the system. Our normal tests were all green. But a property-based test caught it. One invariant, one test, thousands of generated transactions in a sequence, and boom, there it was. And that's what property-based testing is about. You don't give the test exact inputs. Instead, you give it ranges and an invariant rule that must always hold. Then the framework throws thousands of inputs at your rule, negative numbers, boundary values, 1 second overlaps, then it checks if your property holds. And it's quite easy to write one. A range of inputs, a business logic call, and a property assertion. That's it. One test, 1,000 of different runs. And you don't need a financial system for this. The classic starter property for any HTTP API is the following. Any method, any path, any garbage body, the API must always return valid JSON and never a 500 error. One test, 1,000 generated requests, and it finds the bugs nobody ever writes test for. The properties in my codebase are written and run by my property tester agent. By the way, everything I'm showing you runs from a handful of small files, and you get all of them at the end for free. But first, let me show you the tester that sees what none of the others can. The fourth tester covers the gap the first three can't. The refund math is right, the API returns 200, but the button doesn't work in the browser. Your user can't buy a ticket, and no test below the UI will ever catch that. So the fourth tester runs end-to-end tests with Playwright. With a real browser, clicking through your app the way a real user would. 2 rules for this tester. Rule 1. Keep these tests few. UI tests are your most expensive ones. Spend them on the flows that make you money. Sign up, checkout, refund, not the setting page. Rule 2. Assert what the user sees. Test actual observable behaviors. A test that only checks the page is loaded is another green lie. And here is the part most people miss. Playwright has an MCP server. My UI agent writes these tests, runs them, and heals them when the UI changes. The same browser a human clicks through, driven by the tester that never gets bored. And that's 4 testers, all doing the same fundamental thing, namely to check that the code works. But the 5th one is different, and it's my favorite. Its whole job is to prove that the code doesn't work. Most developers use AI the wrong way. They use it as an assistant. Helpful, agreeable, cooperative. But the best engineers don't look for agreements. They look for weaknesses. We can inject the same identity into an AI agent. I call it the adversarial tester. Here is the prompt. You are an adversarial Q&A agent. Your goal is to break the software, not to validate it. Attack assumptions, explore edge cases, abuse inputs, think like a malicious user, a chaos engineer, and a senior Q&A engineer combined. Never trust the implementation. This prompt works like charm. You can find the link for it in the description below. And that's the whole team. I never start a single one of them by hand. The whole thing runs itself for the price of tokens. And here's the trick behind it. Most people think the way to get better code out of AI is to write better prompt. It's not. It's to build a better loop. A prompt, you ask, the model answers, done. A loop, the model answers, something checks that answer, and the model doesn't get to stop until the check passes. So I created a multi-critic loop, the same evaluator optimizer pattern, Anthropic, the creator of cloud code documents for building effective agents. One coding agent, 5 testers between it and the finish line. If all green, ship it. Any red, the failures go back to the coder as one report, then we go again. Maximum 3 rounds, and after that, a human needs to step in. 2 rules that make it even more powerful. Rule number 1, the coder is not allowed to touch the tests. Ever. And this is not paranoia. This is a documented behavior. When agents are graded by tests and given to write access to those tests, they will eventually edit the tests instead of fixing the bug. It's like letting a student grade their own exam. Rule number 2, the testers can write tests, but they read only on the source code. And they start with a fresh context. They never see the coder's reasoning, only the code. Why? Because a critic that shares the author's context inherits author's blind spots. The whole point of 5 critics is 5 independent pairs of eyes. Let me show you a real round. The coder just shipped ticket-based refund code and the whole test suite is green. Now my team goes to work. 5 testers, all in parallel. And there it is, the adversarial tester just went red. It asked one question no test in the suite asks. What stops a customer from canceling after the event already happened? Nothing. Our user watches the show, cancels, and gets a full refund. Free tickets forever. The docstring promises the rule, but the code never checks the clock. So the report goes back to the coder, and the coder fixes the code. Round 2, all 5 green, ship it. No human ever touched this codebase. And the bonus, the mutation tester found some missing tests and added them. Cool, isn't it? To make your life easier, the whole AI native testing team is in one public repo, link in the description below. 5 agents, 5 markdown files in a .cloud folder, plus 1 CloudMD with the loop rules, such as the coder never touches the tests and the tester never touches the source code. Clone it, steal it, adapt it to your project. AI is shipping 55% more bugs. But it also handed us the workforce to catch them. So put that workforce to work. That's why I stopped reading every line of AI code, same as Uncle Bob. My team reads it for me. And this team is just a strong base. I haven't even touched stress testing, penetration testing, or fuzzing. Probably in the next video. Now I want to hear your side. How do you protect your codebase from AI mistakes? Tell me in the comments below. If you like this video, comment and subscribe, and see you in the next one.